In our second review lesson, we're going to take a little look at fractions. Now, I'm going to actually ask you to do this a little wee bit differently than most of the lessons in this course. Instead of watching this video and have me go through and explain each of these pieces, of which there are quite a few. There are quite a few different little skills here with fractions that I want you to be confident in moving forward the course. What I think I would rather you do is go through and try these problems with your prior knowledge, see how you do on them, compare your answers to the ones at the bottom. You'll see here we have lots and lots of questions. It looks like a lot, but they're all very, very fast questions. So you should be able to finish it pretty quickly. But at the bottom of all these questions, there are solutions, or at least answers. What you could do is go through and double check to make sure that your answer is correct. And if there's any part that you're not getting the right answer on, then I'd like you to go back through the video and watch the part that you need rather than waste your time on the whole thing. So it'll save you a bit of time if you just immediately try the questions and then afterwards go through the video and see how that works. Okay, so I'm going to continue through with doing this with the assumption that you've already attempted the problems and figured out which ones you're having trouble with. But let's just take a look at each of the parts independently. So for part one, understanding the meaning of fractions, this one's pretty straightforward. Again, I want you to really understand that fractions are just division. It's just something divided by something or something out of something. So for the first part, what fractional part of the whole is shaded? We could take a quick look here. We got 1, 2, 3, 4, 5, 6, 7 shaded, and there are a total of 10. There are 3 more unshaded. So 7 out of 10 are shaded. If 5 children shared 3 apples equally, how much did each child get? Now, I know that most students don't like fractions, and the funny thing is that this question is so much easier if you use them, because trying to figure out this as a decimal can be kind of a pain. But if you just say, well, there are 3 apples divided amongst 5 children, 3 out of 5, that's how much each child gets, 3/5 of an apple. In March, it snowed for 8 days. What fraction of the month did it snow? Well, we know we have 8 parts of the whole. On this one, I think the only tricky part is figuring how many days there are in March. 30 days says September, April, June, and November, so that would be 31. If you don't remember that off the top of your head, don't worry. You can always look it up, and on a test, you would never actually need to know it. It's not going to hurt you at all. Okay, part 2, equivalent fractions. So equivalent fractions basically means, if you think about like looking at a pie and cutting it into pieces, equivalent fractions means that you've got the same amount of pie. It's just whether the pieces are cut into bigger pieces or little pieces, but you still have the same amount either way. So if you have 3/4 of a pie, that's the same thing as something out of 24. Well, what I can do on this is just take a look at the bottom and say, well, the bottom goes from 4 to 24. It's 6 times bigger. There's 6 times as many pieces. So to have the same amount of pie, I need 6 times as many pieces as what's there, which is 3. So 6 times 3 equals 18. And by the way, these are set up kind of informally. There's no x to solve for. It's just a little question mark. So how you format it is really up to you. For question 2, 4/7 equals something over 63. Well, 63 is 9 times 7, so you're cutting the pie into 9 times more pieces. If it's 9 times more pieces on the bottom, it's 9 times more pieces on the top. So you'd have 36 63rds. That's harder to say than I thought it would be. For part 3, 12 to 72, each piece is cut into an additional 6 pieces. So 5 times 6 is 30. And now this one, we switched and we put the little question mark on the bottom, but that's okay. It doesn't really change anything. On the top, we have 5 times as many pieces. 5 times 9 is 45. So on the bottom, we'll have 5 times as many pieces as well. And 5 times 20 is 100. Incidentally, this method can be used to find out percentages. So for instance, this one changed 9/20 to 45 out of 100. Well, out of 100 literally means percent, so this would be 45%, 9 out of 20. Question 5. Change 15 out of 19 to 38ths. So 15 out of 19 equals some number of 38ths. Looks like I'm doubling the bottom to get from 19 to 38, so I'm going to double the top. 15 times 2 is 30. And finally, how many 30-seconds of an inch are there in 5/8 of an inch? So 5/8 of an inch looks like that. And we're looking for the number of 30 seconds that's equal to. Bottom is multiplied by 4, so the top is multiplied by 4. So 5/8 would be equivalent to 20 30-seconds. Easy peasy. Part 3, fractions in lowest terms. So what we're doing here is just looking for any number that we can divide the top and bottom by nicely and try to get rid of it, the excess stuff, so that basically everyone has the same answer. Now, often students will ask me in other parts of the course, should I put my fractions in lowest terms? And the answer is yes, always yes. It's always proper to put your answer in lowest terms. It's like asking your English teacher, for this essay, do you want me to spell correctly? The answer will always be yes. Okay, so 14 and 35. Now the number that we can divide both of those by happens to be 7, but you should always start by just looking at the easier numbers to divide by. Is it divisible by 2? 35 isn't. Is it divisible by 3? Neither of them is. 4, it won't be divisible by 4 if it wasn't divisible by 2. 5, the bottom is, but the top isn't. 6, well, if it was divisible by 6, it would have been divisible by 2 and 3. So 7, I guess, is the next one we'd check, and sure enough, that one works. So if I divide the top by 7, I get 2, and if I divide the bottom by 7, I get 5. Now this one here, I'm just going to make an observation and say it looks like both of those can be divisible by 4. However, if you missed that, and you didn't catch that, and you said, well, they're both divisible by 2, you can always do it, and then if you get an answer, you can try to see put it in lowest terms as well. So 12 out of 28 could be 6 out of 14. That's dividing top and bottom by 2, but now I make the observation that I can divide both of those by 2 again to get 3 out of 7. And 3 and 7 happen to both be prime numbers, so there's no way that they're going to have any common divisor. Now, if you just saw that it was divisible by 4 in the first place, then by all means, do the division by 4. Likewise with this one, 6 over 12, I think it's pretty obvious what this one is, but if you said, well, they're both divisible by 2, I could divide them by 2, go for it. If they're both divisible by 3, which they are, go for it. Turns out, though, they're both divisible by 6. Top divided by 6 is 1, bottom divided by 6 is 2. And again, I think by observation, 6/12 equals 1/2 seemed pretty obvious. Okay, this one. You can keep going and trying to find the biggest number. I could divide by 2. It's not going to be divisible by anything odd, I don't think, at least not nicely. I think the biggest thing, though, that we can pull out of this is 8, which would be 5 over 8. Divide the top by 8, divide the bottom by 8. Now, again, I just want to point out that if you hadn't seen that, which, I mean, a lot of people don't notice bigger divisors right off the top of their heads, you could always divide it by 2 and get 20 over 32. And then divide that by 2 and get 10 over 16. And then divide that by 2 and get 5 over 8. So you'll get to the end either way if you start off with the smaller numbers. And again, just start with the smaller primes, 2, 3, 5, 7. If it's bigger than that, it's probably going to be something obvious or something that I wouldn't expect you to see. All right, 16 over 96. Now, I think that's divisible by something large, but you know what? I'm going to just do this the easy way. Divide top and bottom by 2, and that'll be 8 over 48. And then I'm going to notice that actually, yeah, both of those are divisible by 8. So that's 1 over 6. This one, I notice that 65 and 80 are both divisible by 5. 65 divided by 5 is 13. 80 divided by 5 is 16. And 13 is prime, so that's done. That's as far as we can go. 49 over 63. Not divisible by 2, 3, or 5, but they are divisible by 7. Divide 49 by 7 to get 7. 63 by 7 to get 9. 7 is prime, so there are no more divisors. And this one, you could check your prime numbers, but I think if you just look at the number closely, you'll see that 83 divided by 83 is just 1. And that's it. So a reminder, always, for all your answers, regardless if the question states it or not, answer fractions in lowest terms. If they're really super nasty and maybe they're huge numbers and the only divisor happens to be 1,326, I'm probably not going to give you anything that nasty, but if I did and you didn't see that, I would definitely be forgiving. Okay, part 4, expressing whole or mixed numbers as improper fractions. So in real life, we often like to use mixed numbers to represent things. For instance, shoe size. We say something like my shoe size is 10 and a half. We don't say it's 21 halves. But in math, it's really difficult to work with mixed numbers, so we usually want to convert them to improper fractions, which just means a fraction where the top number is larger than the bottom number. Now, the word improper for the fraction makes students think that there's something wrong with it. That's just the name we give it. They're perfectly valid, and in many cases, mathematicians would much rather work with improper fractions than mixed numbers because it's easier to see what's going on. It's easier to manipulate mathematically. Either way, we want to express 8 as an improper fraction whose bottom is 7. Okay, so the one thing we can do here is think about 8, which is a whole number, as a fraction over 1. And then we treat this like we treated the others, where we're just trying to convert from one form to an equivalent fraction. The bottom is 7 times bigger, so the top must be 7 times bigger, or 56. The second one, how many eighths of an inch are there in a foot? Now, I put a little hint here that there might be something you need to look up. Maybe you don't. Maybe you know how many inches are in a foot, and the answer is 12. So you have 12 inches, and you want to find out how many eighths of an inch that is. So something over 8. Now again, whole number we can always consider to be a fraction over 1. In this case, the bottom is 8 times bigger, so the top must also be 8 times bigger. And 12 times 8 is 96. So there's an equivalent fraction. There are 96 eighths of an inch in a foot. Whew, okay. Mixed numbers. We're going to kind of do the same thing here. We're going to convert each of the whole numbers into a improper fraction, and then we're just going to add on the little bit extra. In this case, we're going to figure out what 4 is as a multiple of fifths, and then just add one more fifth. So I think we can kind of skip this one algebraically and just kind of jump to an answer. 4 becomes 4 times 5, which is 20 fifths, plus 1 fifth is 21 fifths. And the easier way that you were likely taught to understand this or to actually calculate the answer correctly is to just take this little number here and multiply it by that one, and then add the actual extra little piece at the end. So 4 times 5 is 20, plus 1 is 21. We'll use that little trick here. 3 times 12 is 36. That really just means we have 36 thirds, plus 2 more thirds is 38 thirds. And this one, unfortunately, this one looks like we're going to pull out a calculator unless you're good with mental math. Incidentally, I'm good with mental math, but I lose track of things easily, so I will use a calculator for this one. 182 times 7 is 1,274. So that's going to give us that plus 4 is 1,278 over 7. And at this point, you might say, well, wait a second, is that in lowest terms or could it get lower? I know it's in lowest terms because it started off as 4/7, and adding wholes to it won't change the fact that 4/7 can't be simplified. So we can't bring that into lowest terms, so we're good. Question 4. A pizza store sold 32 3/8 pizzas on Friday. If each slice is 1/8 of a pizza, which makes sense, how many slices were sold? Well, that would be 32 times 8, which again, I'll just throw into the calculator, is 256, plus 3 more is 259 eighths. And again, a reminder that you could check to see if that's in lowest terms, but because the original 3/8 was in lowest terms, the answer will also be in lowest terms. It's pretty much a guarantee. Now, if the answer or the original question wasn't in lowest terms, so for instance, if it was 32 4/8, that's 32 and a half, then we could definitely put it in lower terms. All right, part 5. Multiplying whole numbers and fractions. So the rule when we multiply fractions in general is you multiply the top by the top to get the new top and the bottom by the bottom to get the new bottom. If we're dealing with whole numbers, these are really fractions over 1. So just remember that it doesn't change anything. Really, the 1/3, we're only multiplying the top by 24. The bottom's just getting multiplied by 1, so it does not change. So the top becomes 24, the bottom stays 3. And that one obviously can be put into lower terms. 24 divided by 3 happens to be 8 exactly. This one here, we multiply the top only by 32. 3 times 32 is 96. 96 divided by 4. And then 96 is divisible by 4, and that is 24. Question 3. 7/8 times 56. I'm going to show you a little trick here. Really, this is 7 times 56 divided by 8. I'm just going to write that out this way. 7 times 56 divided by 8. So 7/8 of 56 is actually the same thing as 7 times 56/8. It's really the same thing. I'm multiplying the 7 and the 56 and dividing by 8. It doesn't matter when I divide by the 8, truthfully. So 56 divided by 8 is just 7. So this becomes 7 times 7 is 49. Now, if you don't believe me, you can always try this the old-fashioned way and do 7 times 56, which is, ooh, my calculator messed up. I messed up. My calculator did what I told it to do. 7 times 56, I could rewrite this one as 392 over 8. And then I put that in lowest terms, and I'll just divide that by 8 and see what happens. And sure enough, that equals 49. So if you can see a division to make your life a little bit faster and easier so you don't have to pull out the calculator, by all means, feel free to do so. Sometimes that's just not an option. And speaking of not an option, let's go to question 4. So here, 5 divided by 9 times 26 is really 5 times 26 on the top and then 9 on the bottom. Unfortunately, 26 and 9 are not, don't have the same divisors, so there's nothing to do there. So 5 times 26 is 130 over 9. And I can look for lower terms, but there aren't any. For starters, I know that it's not divisible by 9 because I don't know how many of you know this rule, but if it's divisible by 9, the sum of its digits are divisible by 9. And the sum of these digits, 1 plus 3 plus 0 is 4. 4 is not divisible by 9. So we're in those terms. Okay. Question 5. Mrs. Singh earns $720 a week. If she saves 5/12 of her earnings and spends the rest, how much does she save each week? So she gets 5/12 of $720. So that's just multiplying a fraction by a whole number. And I will be honest here, I should be working down instead of across to show that this is an expression, but just because we're kind of out of space, it takes up a lot more paper to work down here, so I'm just going to kind of work across. This would be multiply top 5 times 720 over 12. Whew, that is a big number, but you know what? Let's do it. 5 times 720 is 3,600 divided by 12. And here I'll work down. 3,600 divided by 12 is a nice equal 300. Okay, now another way I could have done this is to think of this as 5 times 720 over 12. And 720 divided by 12 works a little nicer. That's just 60. And 5 times 60 is 300. So you get the same answer either way. As long as you multiply the 5 and the 720 and divide by 12, you could divide the 5 by the 12 or the 720 by the 12 or the whole multiplication of the two things divided by 12. Now, how much does she spend each week? Well, if she spends 5/12, she saves 7/12. And this one, I'm going to take the long way. 7 times 720 is 50/40. Divided by 12, and I check my calculator, and it says that that's 420. All right, now an easier way to do this one would be to say she had $720, she saved 300 of it, she has $420 left to spend. Now, both of those are good. The second one arguably is better. The reason I actually like doing it the first way, to get it this way, is because then I can kind of quick double check my answer. Because if I take that 420 and 300 and I get 720, then I know I did it right. If either of those was an error, I would be able to spot it pretty quickly. Whereas if I did an error in the first part, I would get this part wrong as well. And then I've got two wrong things, even though they add up to 720, but it doesn't show any understanding of fractions. All right, one more. A recipe calls for 2/3 of a cup of beans for each cup of tomato sauce. How many cups of beans should be used if 7 cups of sauce are used? So that's just really saying you need 2/3 times 7. And that one's easy enough, 14/3. Now, 14/3 I could write as a mixed fraction if you really wanted to. 14 is not quite divisible by 3, but the best I can take out of that is 12 divided by 3 is 4, and that would leave an additional 2/3 left over. So you can double check 4 and 2/3 is 14/3, which is probably the way I would express the answer if I was writing a cookbook, because nobody wants 14/3 as the measurement they need to make. And as far as which answer is proper, it's not that one is right or one is wrong. It's think about in real life what kind of answer you're looking for. No one says, how long is this TV show? And someone says it's 11/30ths of an hour. Like, no one's going to answer that way. You say it's 22 minutes or whatever. No one's walk to their house is, let's try a bigger number, 7/3 kilometers. They're going to say something like it's like about 2.3 kilometers, something like that. So make sure your answer kind of makes sense for the questions that are asked. If they're strictly mathematical, like they were up in question 1, then just express the answer however you like. Like our 130th over 9 for question 4 was perfectly valid. We don't need to change that back to a mixed number. Like I said, mathematicians particularly would rather see improper than mixed numbers in most cases. All right, multiplying fractions. We kind of just did this with the multiplying fractions by whole numbers, but this one we're going to be a little bit more detailed. In order to multiply two fractions together, it's really easy. Top times the top gives us the new top. Bottom times the bottom gives us a new bottom. If, in some cases, there's something that we can cancel out because it appears on the top and the bottom, then we do that. So in this case, we don't have to worry about that. The top is just 1 times 1, and the bottom is 3 times 6. This one, top times top is 20. Bottom times bottom is 63. For question 3, we're doing the same thing. We just happen to have 3 of them. 5 times 5 times 1 is 25. 12 times 6 times 2 is 144. Incidentally, I know that that's in lowest terms because nothing on the bottom is divisible by 5, and that's the only real number that we can divide the top by. Now this one here for question 4, 5 divided by 14 times 14 divided by 12. Think about doing this one step at a time using BEDMAS. 5 divided by 14 obviously gives you a fraction. Multiplying by 14 just gives you 5 back because it was 5 divided by 14 times 14. So this is really just 5 divided by 12. When we have the same number on the top and the bottom, it doesn't even have to be on the same fraction when we're multiplying. We can cancel them out because division by 14 and multiplication by 14 are the same thing. Or I shouldn't say the same thing, they cancel each other. And this just leaves us with 5/12. We'll do that same trick with question 5. I can divide the 5/3, I can get rid of the 3, and the 3/8, I can get rid of that. Really what I'm doing is replacing them with 1 and 1. I'm dividing the top by 3 and I'm dividing the bottom by 3. Either way, I'm left with 5/8. For question 6, I could do something similar. 7 and 14 don't cancel each other out. However, I can divide the 7 by 7 and get 1, and the 14 by 7 and get 2. And now I can do 5 times 2 is 10. 1 times 9 is 9. Now I should point out, if you wanted to do this the long way, there's nothing stopping you from doing it. 5/7 times 14 over 9. 5 times 7 is 70. 7 times 9 is 63. And then I can make the observation that both of those is divisible by 7. 70 divided by 7 is 10. 63 divided by 7 is 9. And what you might observe there is that I just took those numbers and multiplied them by 7s just so that in the end I could divide by 7s, which seems like it's a waste of time. So if we can skip that part and jump straight to the 10/9, that's awesome. Okay, 2/3 times 21 over 26. Similar trick here. I could divide this by 3, and I could divide this by 3 to get 7. I can actually do the same thing with the 2 and the 26. 2 is divisible by 2. 26 divided by 2 is 13. And now that leaves me with 1 times 7 is 7. And 1 times 13 is 13 on the bottom. And finally, we'll do the last one and cancel out some excess stuff too. Divide that by 7, divide that by 7. The 9 is, and the 39 are not both divisible by 9, but they are both divisible by 3. So I can divide that by 3. 39 divided by 3 is 13. And one reason I like doing this is because it makes the numbers smaller. I don't have to touch my calculator. And the top we get 3 times 1. And the bottom we get 2 times 13. And we're in those terms. All right, division by fractions. Turns out division by fractions is actually really easy. Even though it seems really confusing, it's hard to visualize in your head what this means. But division by fractions we just do by multiplying. I know that seems counterintuitive. So the first one here, divide 6 by 1/5. So let's say that I had 6 liters of pop and I wanted to divvy it out into cups that are 1/5 of a liter each. Well, obviously 1 liter could fill 5 cups, so 6 liters should fill 30 cups. That kind of makes sense. That's all division by a fraction means, is that you're breaking it into pieces or parts where each part is less than one whole. If I said take 50 things and divide it up into stacks of 5, you'd say, well, there's 10 of them. That's easy. If it's division by a fraction, it's the same idea, you just happen to get more than the original number. Okay, so I'm going to rewrite this as 6 divided by 1/5. And the notation on this is kind of bad actually in math, because that looks like 6 divided by 1 divided by 5. I want to be clear that the big division, if you want to call it that, is the 6 divided by 1/5. And the small division is just the 1 divided by 5. So I did that by making the division line much larger. Now I could also write that as 6 divided by 1/5. That's much more clear on what I mean. There's no ambiguity to that notation. So here's a trick. If I want to divide by a fraction, that's the exact same thing as just saying multiply by the reciprocal of the fraction, which means just flip the top and the bottom. And now I get 6 times 5 is 30 divided by 1. Well, that's just 30. So anytime that you have to divide by a fraction, just flip the second fraction and multiply instead. Easy peasy. All right, question 2. If each book on a shelf is 2 1/5 inches thick, how many books would fit in 33-inch shelf? So we have to take the 33-inch shelf and divide it by 2 1/5 inches. And that will tell us how many books we have. And as we looked at earlier, working with mixed fractions is just a pain in the butt. So what we're going to do is change this to 33 divided by 2 1/5 is 5 times 2 is 10 plus 1 is 11/5. There we go. And finally, we can simplify that by changing the division to multiplication and flipping the second fraction. I just want to be clear, you don't flip the 33 as well, just the second fraction. So that would be 5 over 11. Now just to see this clearly, I'm going to write that again. Remember that this is really a fraction over 1. And we could do that trick that we saw in the last part where I can divide this by 11 and this by 11. And now I'm left with 3 times 5 is 15 divided by 1, but there's no point in writing division by 1 because that's just the same thing. So it turns out we can get 15 books in that amount of space. Dividing fractions by fractions. Same trick, change the second fraction by flipping it and change to multiplication. So this is 2 over 9 times 45 over 8. And then we can go through and use our multiplication tricks and say, I can divide that by 2 and that by 2. And I can divide this by 9 and this by 9. And then I'm left with a really easy 5 divided by 4. Second one. Again, working with mixed fractions is mathematically difficult. So what we're going to do is we're going to change that to an improper fraction. 4 times 7 is 28 plus 3 is 31 quarters. Change the division to multiplication, flip the second fraction. Now this one, I can do a little bit of manipulation there. I'll divide that by 4 and that by 4. And that leaves us with 31 times 2 is 62 on the top, and 1 times 5 is 5 on the bottom. Question 3. Alvin rode his bicycle 4 2/5 kilometers on a circular track that is 2/5 of a kilometer long. How many times did he ride around the track? Now again, people's brains tend to get a little wonky when it comes to thinking in fractions. So think of this as like just whole numbers. If I said the track was 100 kilometers, if he rode 100 kilometers and the track was 10, you'd say, well, wait a second, it's just 100 divided by 10. That's how many times he went around. Here it's the same thing. It's the distance of the track. And we divide it by the length of one run of the track. Okay, let's get away from those mixed fractions because they're difficult to work with. 5 times 4 is 20 plus 2 is 22/5. Switch that to multiplication. Flip the second one. In this case, the 5 and the 5 cancel. And we're left with, I could cancel the 22 and the 2, but either way, it's going to happen in the next step. 22 divided by 2 is 11. So Alvin could ride around the track 11 times. Dividing fractions by whole numbers. This, if you got the last part, this part won't be too bad. 6 over 13 divided by 12. Remember that whole numbers are really just fractions out of 1. And now we just use the same trick we used last time. 6 over 13, change it to multiplication, flip the second fraction. We can do a little bit of simplification, divide top by 6, bottom by 6. And that's going to leave us with 1 on the top, and 13 times 2 is 26 on the bottom. Question 2. A truck is carrying 2 identical tractors weighing a total of 6 7/8 tons. How many tons does each tractor weigh? Now, just for those observant people out there who are going, I don't know, it looks like tons is spelt wrong. I'm going to point out that there are actually two different units of measurement called the ton. There is the American ton, which is the one that's seen most often. That's 2,000 pounds, and it's spelt T-O-N. And then there's the metric ton, T-O-N-N-E-S, which is 1,000 kilograms. It's about 10% heavier than an American imperial ton. So anyway, just I thought I'd point that out. Either way, we're taking the total weight and dividing it by 2 because that's how many tractors there are. So 6 7/8 divided by 2. Let's get rid of that mixed fraction because nobody likes those. 8 times 6 is 48. 48 plus 7 is 55. And we're going to change this to multiplication. And we're going to remember that 2 is really 2 over 1 and flip it. So that's 1/2. Now this one, unfortunately, the 8 and the 2 are both divisible by 2, but they're both on the bottom, so we can't do any cancellation. This one's just going to be 55 over 16. And if you want to put that in mixed fractions, you can, or mixed numbers, but you don't have to. And that would just be, I could divide that by 3, and I'd be left with 7/16. So 3 and 7/16, which makes sense. Half of 6 and a bit is going to be 3 and a bit. And half of 7/8 would be 7/16. Okay, again, I wouldn't be too offended on a test if you left it as 55 over 16. Mathematicians like those. I mean, to be honest, in real life, we would almost never use these fractions in any way. We would just give this as a decimal number and say how many tons it was, whatever it is, 3.4241, I don't know, whatever it is, tons. Okay. Adding like fractions. We're just going to boot through this one. The only thing to remember is when you're adding like fractions, they have to have the same denominator, and the denominators do not add. When I see 2/7 plus 3/7, in my head, I think of that as being like 2 apples plus 3 apples is 5 apples, not 5 apples squared, not anything weird. We add the tops, 2 plus 3 is 5. The bottoms stay the same, because we're talking about how many sevenths we have, so we don't change the number of sevenths. Over here, 1/8 plus 1/8 is 2/8. We can, however, put this one in lower terms, so we should, and that's 1/4. 3/10 plus 5/10 is 8/10, and again, that one can be put in lower terms. That's 4/5. And here we have 3, but that's okay. 7 plus 9 is 16, plus 4 is 20, over 20, hey, that's just 1. Now this next part here is something that actually comes up more than you'd think. I do a fair bit of carpentry work, and the number of times I have to see if I can fit a certain number of small pieces of cuts into one piece of wood is constant. But in order to finish a job, a carpenter needs 3 pieces of wood with lengths of 18 and 4/8, 12 and 7/8, and 6/8 feet. By the way, this is a little fictitious. No carpenter works in eighths of a foot. But anyway, what's the total length of wood they would need? So we're going to do 18 and 4/8 plus 12 and 7/8 plus 6/8. And somebody might be observant and say, well, why did I write 18 and 4/8? That's just 18 and a half. This is true. You could simplify that and put it in lower terms. However, the whole goal here is to find a common denominator, so there's no point in getting rid of it just to find it again. Okay, now we have to go through and rewrite those improper fractions as mixed fractions. Sorry, mixed is improper. So 18 times 8 plus 4 is 148/8. Twelve times 8 plus 7 is 103/8. And 6/8 is fine the way it is. Okay, so 148 plus 103 plus 6 gives us 257 eighths. And I know that in lowest terms because 8 is not divisible by, is only divisible by 2 and 4, and 257 is odd, so that won't work. Now we could, again, if you wanted to, write that as a mixed fraction answer. 257 divided by 8 is 32 and 1/8. So 8 times 32 is 256, and then you got 1/8 left over. Okay, another way that you could have done this one if you really wanted to, and again, this is however you want to do it, I can kind of treat them as two separate things. I could say 18 plus 12, the whole parts, would be 30. And then I could add the parts. 4/8 plus 7/8 plus 6/8. In fact, this is how I'd probably do it, just because it's a little bit faster for mental math. And then we've got 17/8 on the rest of those little pieces. And that's 2 and 1/8, which is 32 and 1/8. So I could have done it a little bit faster doing it that way without a calculator, but either way, you get the same answer. Now, if we want to add unlike fractions, what we have to do is find common denominators. So common denominator of 4 and 7, if you can't see it in your head, the easiest way to find a common denominator is to just multiply them together. So in this case, 4 times 7 is 28. Now in this particular case, that is the best one. So we'll do it that way. You'll notice I'm not going to write the tops yet. I'm just going to make sure that those are both 28s on the bottom. Those are the common denominators. In order to get the first one to be 28, I had to multiply the bottom by 4, so I'm going to multiply the top by 4. And for the second one to get 28 on the bottom, I multiplied the bottom by 7, so I got to multiply the top by 7. And 4 out of 28 plus 21 out of 28, we now have like terms, is just 25 out of 28. And that can't be simplified any lower. The next one, I could find a common denominator by multiplying 6 by 9 and getting 54, but I think I can find a smaller one because I noticed that both of those are multiples of 3. So what I can do is just say, well, multiples of 6 would be 6, 12, 18, 24, but 9's multiples would be 18, so they both can get 18 is a multiple of both of those. All I did was triple the first one, so I triple the top, and double the second one, so I double the top. And that gives me 15 plus 4 is 19 over 18. Now this one's a little bit nastier, question 3. We have a 3, an 8, and a 15, so we'd like the smallest number that's divisible by all three of those. 3 times 8 times 15 would work, but that's 24, 360. I think we can do better than that. So I think what I'm going to try is listing multiples of 15 to see if any of them is a multiple of 3 and 8. So 15, 30 is a multiple of 3, but it's not a multiple of 8. 45 is not a multiple of 8. 60 is not a multiple of 8. 75, nope. 90, nope. 105, no. 120, yes, hey, 120 works. All of those are divisible by 120. So in order to get that, I had to multiply the first one by 40. So that's going to be 80 on the top. And the next one I multiplied by 15. 7 times 15 is 105 on the top. And the last one I multiplied the bottom by 8, so I'll multiply the top by 8. And that gives me 80 plus 105 plus 88 is 273 over 120. Now 273 is divisible by 3 actually. I believe 273 divided by 3 is 91. So I could divide that by 3, and I have to divide the bottom by 3, and I believe 91 is prime, so I don't think we're going anywhere from there. Now, I just want to point out, if you really, really wanted to, you could have just said, let's do a common denominator of 360, which is multiplying 3 by 8 by 15. That's multiplying the bottom by 120, so that's 240. Bottom here is multiplied by 40, that's 280 on the top, and the bottom is multiplied by 24. So 24 times 11 is 264, I think. Oh, I have a feeling I'm messing this up. 240 plus 280 plus 264 is 784 3/60ths. That one's nasty. They're both divisible by 2. So I can divide them by 2 and get 392 over 180. Those are both divisible by 2. I get 196 over 90. And at this point, I'm relatively sure I made a screw up somewhere. Give me a second to see if I can find it. I got it. I think this number here should be 315. Okay, I'm not going to go back and fix that because we do already have the answer. It's right here. It's 91 over 40th. But I do want to point out that you can always go with the bigger common denominator. You don't have to go with the lowest one. It just is going to get messy. The numbers are all going to get larger and you're going to have a harder time putting it in lowest terms. So if you can find a lower common denominator, by all means, go with the lower common denominator. That's the moral of the story. So we'll just pretend this never happened. All right, question 4. This one, same thing. We hate mixed fractions with these questions, so we're going to try and get rid of them. The first one's pretty easy. 10 times 17 is 170 plus 3. And this one, this one's a calculator one. 21 times 35 plus 4 is 739 35ths. Okay, those are not pretty. Lowest common denominator there, well, a common denominator would be 10 times 35 is 350, but I think I see a much prettier one, which is just 70. So 2 times 35 and 7 times 10 both give 70. I don't know why that keeps popping up at the bottom on me now. Okay, either way, I multiplied that first fraction by 7 on the bottom, so I have to do 173 times 7 on the top, which is 1211. Just a sec, that's annoying. All right, can't make it go away, but I'd rather keep it there permanently than have it keep bouncing back and forth. Anyway, second one, I doubled the bottom, so I just doubled the top. 739 times 2 is 1478. And then add those two together. 1211 plus 1478 is 2,689 over 70. Now, I'll be completely honest, I'm not sure if that's in lowest terms, but 70 doesn't have that many factors. It can be divided by 2, but the top's odd, so that doesn't work. It can be divided by 35, but yeah, that's not going to work because the top doesn't end in a 0 or a 5. I think the only option would be, could be 7 or 10. It's not 10. Maybe it's divisible by 7. 2989 divisible by 7. It does not work. Okay, so we've checked divisibility by, I think, all the things that matter. So that's not going to be divisible. That should be in lowest terms. And again, on a test, if you got something that was that nasty and it turned out that there were lower terms, I would probably forgive you on that one. I just hate seeing things like 8/16 on a test. That's really annoying. All right, one more to finish off our talk on fractions, and that's subtracting fractions. The good news is this is done exactly the same way that we did adding, except that we're subtracting instead of adding. So the first thing we have to do is find a common denominator. Common denominator of 8 and 3 is 24. Again, this is just my tip. Whenever I'm doing this, once I found the common denominator, I write it out and then I figure out the tops later so I don't lose track of where I am. First fraction multiplied the bottom by 3, so I'll multiply the top by 3. Second one, I multiplied bottom by 8, so I'll multiply top by 8. 21 minus 16 is 5 over 24. 6 and 7, common denominator is 42. Bottom got multiplied by 7, top gets multiplied by 7. Bottom got multiplied by 6, top gets multiplied by 6. 35 minus 18 is 17 over 42. 17 is prime, so we're done. This one, we're going to change to a mixed fraction, to an improper fraction from a mixed fraction. The numbers aren't going to be particularly pretty, but you have to be careful on these. So I know some people will do 15 minus 11 is 4, and then they'll do 17 over 24 minus 5 over 8, which works if the number's positive, and if it's negative, it gets a little confusing. So I'm just going to do this, I'm going to do improper fractions the proper way. So the first one's 15 times 24 plus 17 is 377 over 24. The next one is 11 times 8, and then add 5 to get 93 over 8. And now I notice the lowest common denominator is just 24. So the first one doesn't have to change at all. And the second one, to get 24 on the bottom, I got to triple the bottom. So the top I'm going to triple as well and get 279. And then the subtraction, 377 minus 279 is 98 over 24. I will apologize. I'm going to work across a little bit just because I'm kind of out of room. But I do notice that 98 and 24 are both even, so I can put them into lower terms. That would be 49 over 12. And 49's only divisors are 149 and 7, so I think we're done. All right, last one. So again, if you choose to do this one kind of the way that I mentioned for the positives, or the addition of these fractions, you could do 18 minus 8 is 10, and then 2/5 minus 2/3, but you're going to get a negative for that part, and then you've got 10 minus something, and it gets kind of weird. If you do it that way and you're getting the answers right, by all means do it. I just don't really teach it that way. So we're going to change this to improper fractions. 5 times 18 is 90, so that's 92 over 5. 3 times 8 is 24, that's 26 over 3. And the common denominator of 3 and 5 is 15. So the first one, I had to triple the bottom, so I'll triple the top, that's 276. And the second one, I multiplied bottom by 5, so I'll multiply top by 5, that's 130. 276 minus 130 is 146 over 15. 15 is divisible by 3 and 5. 146 is not divisible by either of those, so I think that's in lowest terms. Incidentally, if you do write that as a mixed number, I should point this out, what you'll get is 146 minus 9 times 15, so you get 9 and 11/15. And if you do it that way from the beginning, what you end up getting is 10 minus 4/15, which will give you the same answer. But I just prefer when I'm doing negatives to not do that little trick. Just do it out the long way, and it always gives the right answer. Okay, final question for fractions. Allison is 5 5/12 feet tall, and her sister Jessica is 4 2/5 feet tall. No one in the world measures feet in fifths, but whatever. For this question, we'll do it. What is the difference in their heights? So we're going to do Allison's height, 5 5/12, and we're going to subtract off Jessica, which is 4 2/5. Step 1, we're going to convert both of those to mixed fractions. So that's going to give us 65/12 and 22/5. Then we'll convert that to common denominator. Unfortunately, I think the lowest common denominator of these is 60, which means I took the first one, 65, multiplied it by 5 to get 325. Second one, I have to multiply by 12 to get 264. And 325 minus 264 is 61/60ths. Which this one's really easy to change back to mixed if you want to. That's 1 1/60th. So Allison is 1 1/60th feet taller than Jessica, or Jessica is 1 1/60th feet shorter than Allison. All right, I'm going to leave there just mentioning again that if you did watch the video before doing the questions, all the answers are at the bottom. You could double check them and make sure that they're all there. And if you have any questions, you're not getting the right answers, it's not agreeing with the bottom, just make sure you contact me and I will help you out as best I can. Until the next lesson.